I'll be your interviewer for today. There will be multiple sections that I'll be explaining you, on which we will be conducting the interview. And I have close to 12 years of experience, out of which most of the experience is in data engineering. And I have worked as an IC, I have worked as a manager. So, yeah, that's more about me. And because I have to speak and then check mark the answers, just I'm just
Okay,
yeah.
sure.
Yeah,
So
you can tell me about.
yeah, let me introduce myself. So I am currently working as a data engineering manager at a company called Now Work Technologies. So I have almost 13 plus years of experience. Uh,
Okay.
um, Among that, like 12 or a little bit north of 12 would be in data engineering. Um, Currently, my role is basically comprises of two parts. One is the technical manager or the people manager, and the second part is basically working as an architect,
Okay.
data.
Okay. Okay. And this interview round will be more focused on data streaming, Databricks, and data modeling.
Got it.
Okay. I'll start with the data pipeline. Okay. So just imagine that we have a data streaming pipeline. We have to design a data streaming pipeline in Databricks that ingest clickstream data from some web application, maybe just like Amazon, and you have to write the output to a Delta Lake for analytics and do some performance enrichment using some product catalog. So, how would you design this pipeline to ensure? So, I'll write down few points. You can write it down for efficiency, for tolerance, and scalability.
Sorry, after what's the last?
Scalability. Yeah. So clickstream data you are getting from web application. You have to design the data pipeline in Databricks, and have to take care of these three metrics. And you have to write the output into a delta table.
Uh, okay. So, uh, couple of questions before jumping on it.
Yeah.
So, uh, one question from the functional requirement: are we going to do any kind of aggregation on the streaming data?
Yeah,
Or
we can do that. You can think about it later also. Absolutely.
and um, uh, so you mentioned about efficiency, fault tolerance, and scalability. What kind of scalability are we looking like? Are we talking about 100,000 users or a million users?
We can start with a million users. This is 1 million daily active users.
Got it.
You can say DAO.
And um, about when you say efficiency, so are we like how we will measure efficiency? Like, are we going to create some dashboard or reportings? Um
Oh, so it's more on the user experience. We don't
yeah,
really want
like
to.
after capturing the data, like is there any end consumer who has a SLA of, let's say, 5 minutes or something? They want their dashboard to be refreshed every 5 minutes or something.
Okay, maybe we can have a 10 minutes SLA for refreshing the dashboard.
fault tolerance. Got it. So, so what I'm going to do is I'm going to talk while I'm trying to write kind of what would be the main uh, components of this architecture.
Okay, I'll just stop you before that. So, this interview will have six sections:
Okay,
data pipeline, data streaming with SQL. I don't know if you can see those sections.
I can see only three: data streaming, Databricks, data modeling.
Yeah, these are three main sections and then two subsections from each. So you don't have to design a complete like a it's not really a system design interview. I know you were going there, but it's like we will have 5 minutes for every section, 5 to 10 minutes, 8 to 10 minutes from for every section. You don't really have to design anything. Okay,
Got it.
what we can do is maybe this is a uh, data pipeline question. So maybe we can think of how we are going to ingest the data. Do we have to do any schema management? How we are going to transform the data?
Yeah,
What we can do for fault tolerance? And anything we can do for maybe monitoring? And how we gonna write the data? Like write the output of a delta lake table. Maybe use some partitioning, bucketing. These kind of questions you can answer. We
got
can
it.
start with maybe ingestion. How you're gonna ingest the data?
Sure.
What do you
So,
want? Yeah.
so basically, a clickstream, like the example you gave,
Yeah.
either we are capturing something like from Amazon or from a social media um, application.
Hmm.
So, so those are my data sources. At the first, I will have a Kafka or similar to Kafka and ingestion solutions,
Yeah.
basically a PubSub. Once I have the Kafka, like let's say I'm using Kafka streams or Kinesis, whatever, from there I will have uh, a processing framework, which in this case, the requirement says like I have to use Databricks. So I will use Databricks streaming. Um, Kafka allows a schema registry where I can define the schema registry of the data. Now, quickly, 1 minute on Kafka, there will be different partitions, or sorry, different topics. Different topics will have different partitions for the scalability. So topics will be basically for different kinds of microservices. So if we take the example of Amazon, like one for orders, one for cart, one for something, etc. Uh, wish list, etc. From there, in the Databricks streaming, after ingestion, like we are talking about aggregation. So either I'm doing some kinds of aggregating using a windowing function like a session window or a tumbling window and that kind of thing. Uh, uh, Based on that calculation, there can be two paths. One path, sorry, actually after Kafka, it will be two path. One path will be kind of a real-time computation, which Databricks streaming will be doing, and then storing that data into a um, kind of a, you can say, a cache database like a Redis or something, or Dynamo, which can be eventually produced, which can eventually be utilized to produce dashboards or reports. From the Kafka, the second path would be basically writing that data into a blob storage, let's say S3. Now, there can be two use cases. Either we want to use some kind of a batch mechanism on those blob storage data, or again, we can use a kind of a database streaming. But a streaming would be overkill because we are already using that and then computing whatever we need on the fly. So I would use rather a Databricks like without streaming, like batch processing, and then create a
How big of a batch you are expecting to
uh,
do?
so so yeah, so if I have a 1 million daily active users, so I would be like a keep a smaller batch size, like 15 minutes, 10 minutes to 15 minutes batch size. and I will be maintaining a medallion architecture in S3, bronze, silver, gold. So
One question. So suppose you are ingesting data from Kafka to and writing it to S3. How will you change the default storage capacity or storage time for Kafka?
yeah, so basically, I will create two different consumer groups. One consumer group will be the Databricks streaming, which will be have a less waiting time and smaller fetch size as well. On the other side, the consumer group, which is writing the data into S3, that would be larger waiting time, what I already mentioned, like 10 minutes or 15 minutes. And the fetch size would be also like, if we have that much of data into the buffer, then it will go and write the data in S3, the consumer.
Okay. What are the issues do you see whenever you design a data pipeline? Let's say I don't want to write duplicate entries into my final output. How would you avoid that?
Sure. So again, because in the current pipeline that I have designed, it has two kind of path, active path, like real-time path and the batch path, because it's a Lambda architecture. So here the duplicates will be handled separately. So for the aggregations for the real time, it will be handled in the streaming. Deduplications will be handled. Let's say we are using event time as our ingestion timestamp. So I will be using that to deduplicate. I can make a composite key as well. Like let's say event time with a um, event ID or a user ID or something like that. Um, on the other side, on the bad side, uh, like I mentioned, I have a medallion, uh, bronze, silver, gold. Yeah, one thing. So I will be using as a delta lakes, delta table in those architecture using the Parquet file format. Now there, basically the bronze is my landing zone where data is being consumed and stored from Kafka. From there, and the second, which is silver, I'm doing deduplication, data cleaning, data normalization, those things. So there also I can a kind of a so what I'm doing is I'm doing some kind of a CDC or upsert mechanism or merge. In Databricks they call it merge. So I'm using a merge where I'm deduplicating based on again a user ID or event timestamp or depending on the use case as well. But I think user ID and event timestamp would be good enough.
Okay. Yeah, that's it. Just need to. So next question would be. So next topic is data streaming with SQL. Okay. So let's say you're using Databricks SQL and you have to build a real-time dashboard. A bit similar to this, maybe you are getting data from IoT sensor, data streaming into a delta table.
Okay.
So you have to describe how you would use SQL to implement a streaming aggregation that calculates the average temperature. Let me see if I noted down a few questions. Let me see if I can just copy paste here. Let me write it down.
Sure. Um, So, uh, because I have not used Databricks streaming firsthand, so I don't know the exact commands, but I know the Flink commands. I'm assuming it would be similar or yeah, similar, like just the syntax changed, I would say.
Don't worry about syntax here.
So I would say that, let's see.
What to do is you have to calculate average temperature over a 10-minute window with 5 minutes of late data.
Lateness allowed.
Yeah.
So let's say I'm calling this as a temp IoT. Um, Now this would be basically, so again, yeah, just the syntax are here and there, but basically,
You might want to add here device ID. So for every device you have to find out.
yeah, so it would be partition by, let's say, this, something like that. Then we have command the Flink where we will decide, let's see, initial define in seconds, and so what I'm doing is basically taking the partition based on device ID and the event time. Sorry, timestamp here. Um, so yeah, partitioning based on the um, device ID, and then using a window where window I have used in seconds, like 10 minutes multiplied by 60. And in Flink, they have a lateness, allowed lateness, which I'm using for 5 minutes. So what it is going to do is, um, I think I have, yeah, this handling, so I have to parameter handling. Um, so so what it needs to do, it needs to be a moving window, a tumbling window, rather than a sliding window, and it's allowing the lateness. For example, let's say a time span of um, um, 10 to 11. That's the like right now it's or 10:30. So what it will do, it will create that watermark and then wait uh, whatever data has been consumed, and wait for 5 minutes, and then compute, and then produce and then store it in the final table. So basically at 10:35, it will produce the result for the 10:30.
Okay.
And if any event before event timestamp of before 10:30 appears after 10:35, then it will discard.
Okay. Okay. We can move to the next section. Next section is data partitioning. So partitioning in Databricks or in general also. So suppose you are working with a large e-commerce transaction dataset, which is present in Databricks. So can you explain how would you use maybe range partitioning, composite partitioning, bucketing to optimize both read and write, and what will be the trade-off, and how would you decide which one to use, what to use? Let me know if you want to repeat the question.
No, I'm good. Thank you.
Okay.
So basically, the whole idea of partitioning is um, we can retrieve data at a easier and faster manner. So partitioning allows data into to store data in the respective um, grouping or partitioning that we do. for the data. So, for example, for the e-commerce, let's say we want to do a partitioning based on the geographical data and the timestamp. Why I said geographical data is geographical data can be a country or I would say
Yeah,
for
yeah, that's fine.
the e-commerce country is better because it varies from country to country. So like country, India, year, month, day. So whenever we are reading the data or build a query, so it's not going to read all the bucket rather than going to that particular country partition and to the respective um timing date timestamp window, like whenever it is starting and whenever it's ending, that kind of thing that it helps. Now, the second part of the question was what kind of partitioning do I want? So
Mm.
um, for this particular example, I don't think range partitioning would be better. Range partitioning usually works better for when we have any kind of time series data. So let's say the previous example, the IoT data. So I would say the range partitioning would work better there. We can partition better with
But
the
what if we have time series data? We have we will, so for an e-commerce, we will have transactional data, right?
yeah.
Then you can use range partitioning there.
Correct, correct. But I was just thinking about um, the usual data like orders or those kinds of things. Those are time series. Like we can store them as a time series, but rather than they are how do I say, we we want them to be stored um, as a hash partitioning rather than as a range partitioning, because in the range partitioning, like let's say we don't want to take out an average of last 30 minutes of order. We sometimes we require that, but that's not a how do I say,
Why would we store e-commerce data with range with hash partitioning?
um, let's say we want a kind of a how do I say, again take the example of orders, like
Mm. Okay.
or product rather than product, which particular product has been ordered for different regions, or what is we want to understand the demand and scale of a particular product. So I think there it helps better to retrieve if we hash them and then store it. The retrieval will be faster compared to range partitioning,
Sorry, can you repeat the last line? How retrieval will be faster?
because so each product will be a hash and then their username, or not username, the user ID and the order ID, whichever we want to track. I think it would be better to user ID and then the next like that can have user ID and those things. So I think to retrieve them, it would be better and faster
Okay.
because one particular product can be ordered, I don't know, like n number of times, especially
Yeah.
the fast moving good.
And how will you use range partitioning here? Because you will have transactional date, transaction date.
Um, I think I would use. So, for example, let's say we are also tracking users' activity events. So, for them, we can use the event ID timestamp to store as a range partitioning, or just because I'm not um, able to think like why would we need orders to store as a range partition, because if we are storing orders as a day or a month, so usual the requirements are how many orders we have received or we completed for past 1 week or a day or a month.
Exactly. So when you have transaction date, you can find out like which days are better for, maybe let's think about Amazon. On which day Amazon is selling the highest number of orders for a complete week. or maybe when Amazon have a sale for like 5 days, which day was the best one?
The the highest sale was done. Yeah. Yeah, I think in that manner, yeah, we can use the range partitioning, like you said, either 24 hours, like the day start and end time as the partitioning column, basically the date timestamp, or the like the year, month, day, and then that kind of thing.
And okay, so how can you make use of these partitioning technique when it comes to reading and writing? Reading, you mentioned that suppose we are storing data for a country specific, that our query will read just that data for that country. Okay, maybe it is right. It is right. Let's say you have 10 countries data, but India and China are also there, but
Mm.
Namibia and Congo are also there, which are very small countries with less population. So, even if you are still uh, querying the India partition or China partition, I will say still the data will be so much,
Big compared to any smaller country.
yeah, any other partitions, right? And there will be a problem of data skewness also.
Yep,
Some partition will have billions of rows of data, some may have 10 million maybe.
correct.
How will you resolve these two problems? Like, I mean, even though you have done partitioning, but two partitions are just so huge, and how will you simultaneously remove the data skewness?
So I think for these kinds of scenario, there's a concept called bucketing. So the example like you took, the first example, the smaller countries. So let's say Namibia or whatever, Zimbabwe, Kenya, or any other smaller countries. So we have to analyze and we have to understand how many transactions are, or whatever transactions, orders, events are happening for them compared to other, and can we bucket them? Can we bucket multiple countries, or yeah, I think that would be better to avoid the skewness. The other question that you asked about the uh, how we can avoid the skewness. Even let's say in a particular country, India, there can be few days very high um, transactions compared to other, especially for sales and other things, other days. So what we can do is we can repartition them, those high skewed partitions, based on there are different techniques, like sorting, or basically introducing a random number, and doing the repartitioning, and then try to distribute them. Um, and yeah, I think
Okay. And how would you help? How would it help in right
right.
optimization?
Sorry, yeah, I missed that. So uh, we are using delta tables to write the data, and yeah, to store the data. Now delta tables usually have a log file where all to make it acid, acid capability. So if we don't have partitioning, then that log file will be very big. Have partitioning, then that log file will be per partition, and then it is smaller. So whenever we are doing any kind of insert, it is easier to update that, and then similarly for the reading as well.
Can you see the questions when I add them?
Last you added the SQL question, that's what I saw.
Okay.
Oh, sorry, on the left side, you is it like the problem statement?
Yes, you can see, right?
I will just read out what I'm seeing.
You receive a data set with inconsistent formats.
Yes, yes.
Yeah. So this is a question. It's just easier to.
You receive a error. Uh, so, um, basically, so I'm repeating. When you say inconsistent formats in the address fields, it is basically pin code mismatching, or usually, especially in India, they don't have the street name and then like the structure. You're talking about that, right?
Sorry? Yeah. Yeah, yeah.
Okay. So we will first tackle the address fields, the inconsistent address field. So what I will do is I will try to split the address field into like comma separated, or something like that, and try to find out address one, address two, city.
Can you write down few lines of code which you're going?
Um, yes.
You can directly use regular expression. That's fine. I don't expect anybody to
Yeah.
remember
Um,
expressions. Yeah.
Basically, yeah, either we can have this kind of split based on um, comma separated or something, or regular expressions, regex to split it. Now,
If you
let's
have to, maybe you have to fill missing demographic data. Maybe age is missing, gender is missing. Can you write it in one line? How will you do that in data frames or data set?
uh, let's say,
Let's say age is missing and you want to add zero.
okay, so
Let's say gender is missing and you can add unknown.
something like this.
Can you do it in one line?
Um, one line, can be one line. I would say I have to use with column.
No, with column you can, what you can do is you can just write down age as zero, gender as maybe unknown, and date dot fill, something like that.
Yeah.
That will suffice. Next question is related to data modeling. Okay, just okay. So the question is, maybe you have to build a data model uh, for a customer analytics platform,
Okay.
and the requirement for that is that they need to support fast retrieval of recent activity and
Okay.
efficient historical. I'll just copy paste the question here for so you can see it easily. Yeah.
question. Do
Yeah,
we want this data model in a RDBMS, or is it, or in RDBMS, or in Delta Lake,
any OLAP.
any OLAP?
Yeah, not OLTP.
Got it.
So we can break it down into smaller pieces so that,
Yeah,
let's say, in terms of retrieval, what will we use? Let's say in terms of historical analysis. Again, you don't have to design anything here. Okay, maybe what will you do to archive the data? Yeah.
yeah.
And
Um,
anything on the compliance side if you have some experience there.
sure. So, so like you said, it's for like I can use any OLAP, and I'm assuming data size is actual big data, like in terabytes or in petabytes of data. So I would be using like Snowflake, uh,
Okay.
because kind of it can achieve, I would say,
That's fine. You
three
can use
three
you can
protocol.
use Redshift, you can use BigQuery, you can use Snowflake. That's not a problem.
Yeah.
Suppose
So
you have to retrieve the data faster. So
correct. So for
what kind of schema you will use?
so in Snowflake, I would be using let's see, a schema of, so when we say that we want the fast retrieval of recent activity, we would be retrieving data or reading the data using a timestamp, um, or maybe a UID, user ID. So what I'm thinking is to create a, schema where uh, the data is partitioned and clustered using timestamp and UID in the table, and uh, let me write, yeah,
How will you partition it by?
by UID and a kind of a, let's say, on an we want like a hourly basis. That's the uh, kind of the smallest window that we are looking at, or whatever.
Yeah,
So
that's
based
that's correct, but you don't need to partition it by UID. Just the timestamp or the recent date is fine.
yeah, again, it like what kind of requirement is this? So yeah, I think the majority of them are using the time base. So yeah, we can do that. Um,
Okay, for historical analysis.
for historical analysis, again, I would do Snowflake table, or table. Sorry, I would say again a schema rather than not table. In that, the SLA would be uh, older than, I don't know, like maybe 1 day or something. The data will be moved from the
You don't
uh,
have to type, we can just talk.
okay, the
Yeah.
data from the retrieval schema can be transferred to the historical schema. There, we can usually cluster by the data on the most frequent uh, columns which are we are using in the where clause or joining columns. I will skip the archiving for now. For compliance, I would say that I will use like I will come back on archival, but first doing the compliance. For compliance, Snowflake allows like a kind of a masking, uh, column masking, and those kinds of things. So if there is a downstream table which we want to expose, we can use masking, or we can create a view where we will discard that column and that view will be exposed to the customer.
How
Now,
will you mask it?
sorry.
How will you mask it?
Basically, so masking has different techniques in Snowflake, but masking would be either um, replacing them with a kind of a similar value or random value depending on the use case, or doing a SHA 256 masking.
Okay, so once you have masked the data, where will you store the original data?
So like I said, there will be a view will be created from the primary table. The table will contains the original data, and the view either have that column or don't have, or the mask data or the replaced data.
Okay.
Uh, Now coming back to the archiving and data life cycle. Um, so not Snowflake, S3. Like let's say we are using Snowflake with AWS S3. So in S3 we can move data to different S3 buckets, like archival or frequent or infrequent data. So yeah, we can make those policies like it will change uh, the bucket lifecycle. Rather than from Snowflake, we can set it from the S3 side.
Okay. Okay, and on the archiving part?
Same. Using those bucket lifecycle policies, we can archive them as well. Snowflake has, sorry, S3 has uh, deep archive, infrequent archive kind of bucket, so we can use them as well. Let's say for some situation we don't need data after, we don't query data or we don't require data after 2 years or something, so we can put them archive and retrieve them. They are there, we are not deleting, we are just archiving with lesser cost.
Okay. Okay, this is the last question on schema design. Okay. Okay. So you can just pick whatever database, whatever schema you would want to implement, whether it's Snowflake or flat, and then we can start discussing on that. If you're picking star, maybe have you can showcase why it is ideal, why you have chosen, and why not Snowflake. Similarly, if you are choosing Snowflake, then why not star, and what's the benefit for Snowflake, and why not flat? And maybe if you are picking flat, then why not um, star and Snowflake?
I will go with star.
Okay.
um, the primary reason for that is, you said the reports involve like constant change, frequent changes um, related to product location and time. Now the advantage star has over flat, we have a fact table and dimension tables around it. So let's say whenever there is any change, or either from the source side or from the reporting side as well, what they want to do, they don't have to read the full table, or change the logic. Rather than they will, they can change few joins on the reporting side to get the data. Now let's say there is some changes on the how the source data is generated and how we want to store it. So star, the advantage of star is the fact table. Let's say, yeah, it's for retail chain. So let's say orders table. So we are having orders table. Now in the products, earlier we used to have, I don't know, just creating some example, like we used to have product ID, name, description, and something. Now we are adding a product color or something like that, or product quality or reviews. those kinds of things. So it's easy to change dimension table rather than if we go with the flat, then we have to change the bigger table. That will be costly. Uh, and then, yeah,
But reports don't change a lot. Like
no, no,
maybe
I'm talking about from the source side. Like, let's say source is sending newer data or adding some more data. Yes, the reports as well. You're saying that reports usually don't change, but let's say reports want to ingest or use this data with something else. So it will be only a join for them to create newer data so that they can use in the views, so they can use in the reports. But if we have a bigger table, then it will be, how do I say, few nulls for the previous entries and then something. So it will be incoherent, like it will be not be a coherent data.
okay.
Now, the same thing with the Snowflake, because Snowflake has multiple dimensions table and it breaks down. So it's difficult to manage and maintain. Like the change life cycle will be longer and yes, whenever there is any changes on the upstream. And that will same thing will be reflected on the reporting side as well. They have to change multiple they have to change at multiple places to get the data, fresh data, and um, and that will cost us time as well as storage as well.
What's the disadvantage of Snowflake over Star? And where we can use Snowflake and not Star? Just last question.
Sure. I think the if we want a very normalized data, like pre-normalized 4NF or something like that, then Snowflake is better suited in those kinds of scenarios compared to a Star. And we want to, how to say, we want to trade off the storage cost compared to, uh, like, yeah, we want to trade off the storage cost, then Snowflakes are better. So a scenario would be, um, let's say a financial data model is there where they want uh, very normalized data. When I say very normalized data is, let's say a credit card transaction data is there. So they really want user, then their users demographics in another table, user and then the place where the transaction happened, that and that also they want to be, normalize what kind of category of transaction it was, what kind of store it was, or those kinds of things. So if there is a such use case, then I would say Snowflake schema would be
Okay.
better suited. Yeah, then I think I'm good.
Yeah, sure. Thank you so much for your time and all the best for the next round of interviews. And they will get back to you.
Thank
Okay.
you. Have a nice
Thank you
day.
so much. Bye.